Welcome to all my viewers. In this session now we are going to discuss about deriving the Laplace transform of our function here using the first principle method. When you check in my previous videos, I've discussed on how you can derive all these functions using the first principle method. But here now we are going to use the first shift theorem. When it comes to finding the Laplace transform of our function here, the first thing that we need to understand, we must first get the Laplace transform of t raised to a power of n. And the Laplace transform of t raised to a power of n, we agreed, is equals to n factorial all over s squared n plus 1. To mean that since we are going to carry out our first shift theorem, in the first shift theorem we understand that it is only the term of s that will be shifted. And by doing that we are going to have the Laplace transform of now at t to the power of n is going to be equals to n factorial all over. Here now we are having a positive or a negative of a positive or a negative of at. On our denominator we are going to have s, a negative or a positive of a. Everything will be n plus 1 raised to the power of n plus 1. To mean that when you've been given a function like this one, this is how you go about it. Let us now get into our second example. We have exponential 40 sine our angle there t. Here now we come and get the Laplace transform of sine our angle t. And finding the Laplace transform of sine, we are going to have our angle all over s squared we add to our angle squared. But since it was a first shift theorem and we are going to shift with respect to our exponential here, we are going to shift the term of s with respect to a. Now we are going to have our angle all over. The term of s will be shifted. Here we understand it is exponential positive or a negative of at sine our angle with respect to d, sine our angle with respect to t. On the denominator we are going to have s, a negative or a positive. To mean when you take here to be a positive, our sign must be a negative. It must be shifted with respect to a negative of a. Everything was squared we add to with respect to our angle squared. Let us now get into the cos. The first thing that we said, we come and get the Laplace transform of cos. T, which is equals to, cos is always equals to s all over s squared we add to our angle squared. But since we are going to carry out our shifting method, we must have a positive or a negative of, exponential positive or negative at cos our angle t. Our term of s, we are going to shift with respect to our power. So we are going to shift with respect to the exponential here. To mean we are going to have s, we subtract or add to a all over s. Here s was squared. To mean we are going to have a negative or a positive of A, everything squared we come and add to our angle squared. And that is how you go about finding the Laplace transform of that using the first shift theorem. Let us now find the Laplace transform of our function here. The Laplace transform of our function here, we are going to have sine, the Laplace transform of sine hyperbolic t is going to be equals to sine our angle all over s squared we subtract from our angle here squared. We shift with respect to the exponential to mean that the term of s here we are going to have our angle all over s. We subtract or add 2 because here we are going to have a positive or a negative of a. Everything squared we come and subtract from our angle squared. And that is how you go about finding the Laplace transform of this one.